So in this next session, we're going to talk about the journey that Apollo, a specialist insurance company, have been on with Thorogood over the last couple of years. First of all, to build out the modern data platform and then start using it for analytics and generative AI. We're going to split this session into two sections. So first of all, Trevor Hebron, the head of data at Apollo, will tell us all a little bit more about Apollo and then tell his side of the story in terms of the journey that we have been on together. He'll then kind of wrap up that session by talking about a specific use case that we've partnered on using generative AI. And what I'll do in the second half of the session really is look into that use case in more detail. I'll go into the solution, look at a demonstration, and kind of wrap up by looking at some of the value that we were able to drive using that solution that we've developed together. So with that, I'm going to hand over to Trevor to run through the first half, tell us a bit about Apollo and their modern data platform.
Thank you, James. Good morning, everybody. It's a real pleasure to be here. I always think these events are brilliant, but it's really nice to give a bit of a customer perspective, particularly from someone who's been through it. So I'm going to, first of all, introduce Apollo, because I'm sure it's a new name for most of you. We'll go through, exactly as James said, some of the sort of day-to-day life that Apollo has and the data problems that it tries to solve, the journey we've been on, and then very much that use case that James has just mentioned about some of the exciting things we're doing with our unstructured data. So, Apollo. I'm sure a lot of you know insurance. You've probably got home and motor insurance, but the Lloyd's market in particular in London is a very, very old and very specialist place to sell insurance. I used to come to events like this, and it was very much a case of saying, well, all that big data, high volume stuff was for other companies. You know, it wasn't for an Apollo. We were very much small data. To be honest, the amount of insurance policies we write in a year, you could probably fit on a spreadsheet. We might not have huge volumes of data, but we definitely have huge variety. And so when you start to see some of the use cases we have, it's very much looking at saying, how can we quickly evolve things and how can we give that data in the right place at the right time to our underwriters and our claims handlers to make sure that they can take full advantage of it. So I think it's quite a specialist problem, but at the same time, something that lots of people can learn from. So when I joined the company 3 years ago now, we're quite young. And at the time, we're about 150 employees. We'd been through the difficult sort of everything's on paper phase. And when I joined, we had a chunk of SQL Server, so traditional Microsoft SQL Server, relational database type stuff, and a lot of Excel. That's very typical, I think, of lots of organisations, particularly that sort of 150 type employee type mark. We were hearing this a lot. Just stop me wasting time keying it in. I don't know where it is, and I have to manually manage this stuff. That's what Excel does. It's great. It's probably one of the greatest pieces of software ever written, but by gosh, that EUC world of end users having to move things around through shared drives and web, we needed a better way. And particularly when you look at some of the data sources we were dealing with. So on this side, we've got system-to-system stuff. We did have a chunky IT estate, so policy administration systems, claims handling systems, that sort of thing. But we've also got a lot of other stuff. Lloyd's as a market is very human. It's very face-to-face. So I would be given stuff saying, can you deal with this? And it would be a printed out insurance quote, and on there'd be a load of stuff written in the margin because some underwriter had tried to tackle something over lunch with his broker or something like that, or a claims thing where it's a 60-page loss adjusters report and all that sort of stuff. So data comes in lots of different formats. Still a lot of email, even increasingly now Teams messages and things like that, but a lot of again unstructured data in those sorts of forms. But still the core of the same business problems. This, giving data back to analyse what your clients and your partners are up to, being able to inform your underwriting process. Insurance by its very nature is really just a predictive game of trying to understand risk. Analytics and MI still runs the company. I would imagine for most of you, despite all the sexy use cases that we can talk about, MI is still the one that keeps you awake at night because that committee's got to have the right bar chart just at the right time. Claims processing. Can we try and understand and predict what's going to happen? In the Lloyd's market, lots of claims mature over a long period of time. So it's not simply about, like say with your motor insurance, where you can look at a photograph and make an instant decision. This stuff goes on and on and on. And again, governance and culture. Very much the story around our company, at least, is a lot of moving goalposts. As you think you've solved one problem, it moves. Something's been redefined. We're a company that really prides itself on innovation. And so just when you think you've got a handle on it, the following day an underwriter says, we're going to do something slightly different. So can we get that agility in some of these processes as well? So all in all, the need was this: be modern. We'd just gone to Azure, so we knew we were cloud native, but we wanted to take advantage of modern technology. We needed to grow. Our business is growing, and certainly over the last couple of years, we've gone from that 150 employee mark now to 350 employees. It equates to about 2 billion quid's worth of insurance, so growing very fast. And I need to keep pace with what our competitors are doing, keep pace with what the market is doing. Like I say, strive for that innovation. So to tackle that, we needed agility. So that constant, that's how we measure our progress. It wasn't about ticking boxes per se. It was simply about saying, can we solve those problems faster? And so how did we do that? If I move slightly out of the way. So we'd started with a good data strategy, and I'm sure the guys from Thorogood would say we chose a good partner as well. But on the whole, we wanted to make sure that we'd got the right things in the right order. We didn't want to try and boil the ocean. We wanted to have tangible benefits that we could go build through a number of years. So actually, we started with our foundation. We chose Databricks, our platform. Works really well on Azure. We knew we could get some specialist help from Thorogood, but essentially we, get that not just in technological terms, but also the team as well. We looked at how we wanted to invest in data engineering, how we wanted to invest in good governance, how we wanted to invest in all the MI and analytics, and making sure that the team itself could be self-determining. Then you bring in the data. This is the point where we didn't want to boil that ocean. We knew we had those IT sources. That was the really core structured stuff. We knew we had this big unstructured problem, but we didn't just want to panic and go straight to that and find ourselves stuck in that analysis paralysis. We wanted to get governance right as well. And I'm so glad, as an gnarled old data professional, you wind back 20 years, governance was important then, it's still important now. And I'm really pleased to say that the efforts and the foundations that we put in over the course of this strategy has very much served as well as we're starting to look at those AI use cases, because governance and describing your data really well has still been very, very important for us. And finally, we knew we had a lot of data science use cases. We wanted to do more. Data science, before we started, was a little bit of script on somebody's laptop. Kids coming into the company straight out of university, they know better Python than nearly everybody else. That's the language they want to use. They want to sit on top of PySpark or something like that because it gives them the scale to be able to analyze all the things that they've wanted to try. And so it was about taking advantage of that new set of skills coming in, and can we teach our existing employees to get to the same level? So it was very much a human story as much as it was a technology story. So where we ended up at the end of this sort of first big phase was a data marketplace. I know it's a bit of a cliche in sort of data warehousing terms that you want everything in one place, single version of the truth. We very much take that marketplace type culture of we just bring it in. We want everything so it's accessible. There's a real big push towards self-service behind this. Most of our underwriters are very data aware. Most of our claims handlers are very data aware. So it wasn't about trying to restrict things down to just a bar chart. It was about saying, look, it's there. Can you do it? Can you get access to it? Can you play with it safely? Secondly, that self-determining team. I was really pleased. I can't remember exactly which section of the agenda it was mentioned in this morning, but I have definitely seen the worlds of sort of offline analytics and data science moving very much closer to engineering. And to be honest, my own job title has evolved. I started very much as a head of data. Now I'm a head of data and engineering, because the engineering includes apps and it includes AI and it includes all the other things to try and make this transactional world come to life. And we were very pleased with the choices we made around our technology that has allowed us to keep pace with that. So self-determining team. Despite the help we were getting and despite that merging of skills, we still wanted things to be within our control, and within our control in a small team. So, my data team at the time was about 5 to 10, depending on how you count it. It's not a huge number of people, but we still wanted those skills internally to say, yeah, we can accelerate and get help where we need it, but we can still self-determine. We can still be in control of what we're trying to do. Finally, a data culture. That's the sort of governance on steroids, if you like. We're very lucky in Apollo in that, like I say, we're a very innovation-led organisation. We have an executive team that really pride themselves on that innovation, and therefore they have strap lines like, we want to be a data-led decision maker. We want to be able to make sure there's not a drop of value left untapped from our information and data assets. And so that culture of saying, well, how do we get something that's new, that someone's spotted on a side of a desk somewhere, into the platform, into people's hands as quickly as possible? So really that culture was all about, can we take culture, governance, engineering and analytics, wrap it all together and just measure it through agility. So that's essentially the journey we've been on. And like I say, that big purple box up there, it says a modern data team and modern data platform was something we take really strong pride in. because in essence, that's allowed us to look at the next use case. Essentially, we were only half done. We'd got a data platform. All of our IT systems were integrated into it. So I could go and query a policy. I could go and build a machine learning model over our sort of transactional data. But it was only 50% of the problem. The other 50% was all of those documents, all of those emails, all of that unstructured text and imagery and everything else that comes into an underwriter's hands. So unstructured data, if you can get anything from it, you will change my world, was a sentence we used to get a lot from our underwriters in particular, and particularly the guys who are just saying, well, actually, I've got it in an email. I've got maybe some analytical model over here. I am literally just keying from one to the other today. Never more so in our claims space, which is the use case that we are going to talk about this morning. So yeah, big tick in the structured data box, big cross next to that unstructured data box. And at the time, we're sort of thinking, well, we can hear all these headlines. AI's coming, but it's not here yet. Is that something we can do? Is that something a company like Apollo can really get its hands on? Well, I'm really pleased to say that we tried a few things and sort of off-the-shelf type tools. They're very expensive and they're very, I saw the stuff before about what the difference between out-the-box versus bespoke is. We wanted that control. We wanted to stick to all of those principles that we'd had previously around self-determining team, making sure we could understand what was going on. So it was, can we find a way to harness all this tech we've got, keep that self-determination, reach out to partners like Thorogood to help us and give us that skill gap, but then give us that flexibility going forward. So it was all still very much in line with that strategy. So the brief. Anybody who's been near an insurance claim will know that you get a lot of reports, particularly a big claim. So if you are thinking of like hurricane damage in the US or a ship crashing into a bridge, as I'm sure most of you saw a case like that not so long ago, loss adjusters reports in particular can come in multiple versions and multiple flavours. And there's some of the most basic principles around data can often be lost in the text. For instance, a lot of our underwriters or actuaries in particular are looking for where was the location of the loss. And in a big corporate claim, it's often the broker will just put the head office address of the client. We wanted to see exactly where that was. And if you flick onto page 6 of the loss adjusters report, you'll see it's buried in the text that says, oh, this just happened just on this road, just outside of here or wherever. So how did we get hold of that? That's expert judgment. It's plus really random formats of data. But that's where the value was that we were trying to get to. Secondly, as I mentioned, we wanted to use that existing technology, try and find a repeatable process, despite the fact that formats weren't that repeatable, but that was the goal. And finally, what we were going to do with it. Well, it wasn't simply about just getting data that then disappeared into the air again. It was making sure that we could bank it as an input to our operational processes. We wanted to make sure our claims handlers could get full advantage of it. Secondly, that we could get analytical value from it. So could we put it somewhere that then a data scientist or even just a good old person, a citizen data scientist at their desk could get value from it. And finally, that line that you'll have heard throughout this, maintainable by Apollo. We knew we would have a go and we would probably not get everything we wanted. So could we do it again? And could we change the definition and then do it again? And you know what? Maybe we put it back on the shelf, come back to it in a year when our analytics is established a bit further, and then do it again. So it was very much finding that self-determination again in the whole problem. So that was the brief we gave to our colleagues at Thorogood. And I'm pleased to say we got some fabulous results, but I will let James explain how they did that.
Thank you very much, Trevor. I think a round of applause there. So what I'm going to do now is kind of elaborate on that business case that Trevor's presented around unstructured data, but focusing on that initial claims use case. So the first thing I'm going to look at here is just thinking a little bit more about what happens when there is a hurricane in the US. And I've used an AI-generated image here just to show really, at the end of that hurricane, there is a lot of property damage in this use case. So what happens once the weather's cleared? What are the interactions that take place? And as Trevor's highlighted, in the type of work that Apollo are doing, it's not just a simple interaction. It's not just one phone call and it's all resolved. There's a lot of interactions between multiple parties. So, for example, the first notice of loss, when the insurance company is first introduced to the incident that's happened and the damages that have been created. But it's not just that initial first notice of loss. There's a lot of interactions. The loss adjusters will get involved. They'll put together their reports. There are going to be emails between parties discussing the damages, discussing the incident in question. And actually there's going to be additional information that we want to supplement this with. So information from things like Environment Agency reports that give us more details about the hurricane that's occurred. And all of these different documents come in multiple different formats. And for each claim, there can be 30, 40, maybe 50 of these documents. So what we want to do is turn these PDFs, these images, this web data into something that's much more usable. And as Trevor highlighted, it's something that we can really put into the data platform, use to understand the claim, but you maybe build into some of those actuarial models as well. So I've taken a little example here. So what is the type of information that we're looking for? So Trevor highlighted the location of the loss, but also things like who is the insured, who's making the claim, what is the amount for that claim. So it all sounds relatively simple when you boil it down into the outputs that we're looking for, but it's not really that easy. So even if we can extract all of the information from those different document types, no single document is going to contain all of the information, all of the pieces of the puzzle. So a loss adjuster's report, for example, will only contain part of that information. And we can't always guarantee it's the correct or the latest value. So Trevor highlighted that these things can run over months, maybe years. Values change over time. So there could be values that are out of date. So maybe in the first exchange in this example, the claim was made for £220,000, but then the loss adjusters have got involved. They've reviewed the case in more detail, and this value has been reduced to 200,000. So that's the value that we're looking for in the output, not the out-of-date value. But we are also dealing with unstructured data, so things like email exchanges. There could be things like typos. So not only have we got to extract the information from these documents, but we've also got to get the correct results as well. And really, when we went around considering how to build this solution, we wanted to keep the outcomes that Apollo were looking for front of mind. So as Trevor highlighted earlier, a good part of this is around operational efficiency. So we need to be able to provide accurate results and pretty quickly, so faster than someone is able to read all of the documents and key those results into the system. It also needs to add that analytical value. So not just for this one use case around claims, but also be extensible to other use cases. So Trevor mentioned underwriting, the interactions between underwriters and brokers potentially in the pre-bind process as well. And then whatever we do, this format has to be in a usable format that can feed into other analytics use cases. So fundamentally fit into our kind of modern lakehouse data platform. And as Trevor highlighted at the end, really Apollo wanted the ability to control and iterate on this model. So as new documents come in, maybe we're looking for new bits of information from the data, we need to be able to expand that as simply as possible. So when thinking about this use case, what do we actually need to do? So we're getting all of these unstructured documents in. We need to be able to extract the information from the documents. What we're then going to do is classify those documents. So basically to understand, is it a loss adjuster report? Because we've got business rules that will tell us what is the information I expect to find in a loss adjuster report versus an Environment Agency report. And then we're going to extract those fields, and then we're going to have to aggregate them to get the correct output. So I'm going to jump into the architecture quickly, the overall architecture, and then the solution architecture before I go into a demonstration. So as you heard from Trevor, fortunately for us, Apollo already had a pretty solid data foundation in place in the form of a Microsoft Azure and Databricks Lakehouse platform that we've been building with them for the last couple of years. So when it came to this use case, the problem statement didn't really mean that we had to start again, but it was expanding on the platform for that use case. And there are some key elements to the platform that helped us progress pretty quickly. So we already had a data ingestion framework set up that we really just had to expand to ingest all of those unstructured documents that were stored in SharePoint. Then, with Databricks as a key part of the platform, we already had Unity Catalog set up, which made it much easier to build and manage the AI models using MLflow. And we also had the end-to-end orchestration framework in place that meant we could just fit this solution into that end-to-end flow. Thinking back to Andrew's session, this really is a use case for background processing automation. So what did all of this mean? So it meant that very quickly we didn't need to focus on the platform setup, but ingesting those raw unstructured documents into the platform and building out the application. So as I highlighted earlier, there are four kind of key aspects to the solution. So first of all, we have the document ingestion. So using that ingestion framework to connect to SharePoint, and then using Databricks and Azure Document Intelligence to essentially crack open the documents and extract the information into a usable format. And throughout all of this, we're going to use Databricks to do all the heavy lifting and processing for us. So in the second phase, we have the classification. So here we're going to start using generative AI and a language model to help us review the documents that we're getting in, and for it to classify the documents for us. So to tell us if it is a loss adjuster report, if it's an environment agency report, and so on. Once we've classified the document, we're going to combine that with the business metadata that we have. So that information that tells us in a loss adjuster report, you should expect to find the claim value, for example. So again, we're going to pass the information to a large language model that's going to read through the documents and extract the information that we need. We take that at a file level, so we're going to get an output data object in the data lake for every single file, but what we want really is a single record for each claim. So what is the latest and most up-to-date information? And we're not going to use a language model at this last stage. We're going to use business rules to help us do that aggregation. So is it date-based, or have you found it in the loss adjuster report that should be the golden source for that record? So what I'm going to do is jump into a demonstration. So first of all, if I switch over to a web browser, this is a background process. So what we've done for the purposes of a demo is create a web application, and all I'm going to do in this case is upload some files to it, and we're going to process them as I then walk through the kind of four aspects of the solution and show you the areas we've added customization. I'm going to do it on a sample set of data, so in reality we're processing thousands of documents. I think through the initial phase it was 4,500 documents, but for the purposes of the demo I'm just going to select 6 documents here. And you can see they're in different formats. We've got PDFs, we've got email messages, and so on. I'm going to open those, and I am going to submit and process those. So what I'm then going to do is just jump back and walk you through the key aspects of the solution. So first of all, the extraction. So what we're really trying to do at this stage is turn all of these document types into a usable structure for the language model. So there's actually quite a lot of processing that's going on in the background. We're having to convert all those different file formats into something useful, and we're using Azure Document Intelligence to help us extract from all those different document types and then clean that, get a clean format. And what I'm showing here is the data frame output in Databricks. So you can see we've taken a PDF document and we're now kind of extracting that. What I realized that I should have done is shown you the sample document as well. But what I'm going to focus on in this walkthrough is the kind of financial exposure analysis. So what we're looking for, you can see unhelpfully in the loss adjuster document, which is several pages long, we have some kind of key information. So the total claim amount is 350,000. That's written in a text format. It's also helpfully put it in United States currency. But what we actually need in the data platform is 350,000 as a numerical value and converted into the kind of currency code, which will be US dollars. So we've got to take that format, we've taken the format out of the document, we've got it into a usable form in Databricks. This is where we then put it into the classification process. Now, don't try and read through all of the very small text on the screen. I'm going to pop out the bits that are useful. So what we're going to do is see how we kind of identify that loss adjuster report and use the language model. And the whole kind of process is driven by metadata. And there are two types of metadata that we're going to use in the background. One is the system metadata. So if you do look a little bit closely, you'll see we've defined things like the system prompt telling the model how we want it to behave. But here we're also kind of building in that optionality. So the language model that we're using is defined as part of the metadata. If we want to change to a different model, we can simply update the metadata. But we also have the document metadata. So what files we expect in those loss adjuster reports, the environment agency reports, and so on. And this is all used dynamically to generate a system prompt. So I will give you a few seconds really to kind of skim through and look at the key aspects of this system prompt. But ultimately what we're doing, as you read through, I'll talk through some kind of main parts of it. We're telling the model how to behave. So we're giving it kind of a brief to the task through a document classifier working for the Thorogood Insurance Company. We have these different types of reports that we're looking for. So you've got a high level kind of, what are the keywords you might be looking for as you classify an adjuster report, but then a much more detailed description at the bottom about what the adjuster report is. So giving context to the model so that it can give us the kind of results that we're looking for. And we get an output. So we pass the documents in, it reads through them, it uses those instructions to classify it. And you can see in this example, one of the documents we've uploaded is the loss adjuster report. We've also asked the model to tell us how confident it is in its classification. We see 1, that means it's 100% confident in the classification that it's made. It's also given us an explanation. So why does it think this is a loss adjuster report? So if we want to do some tuning in the background, understand why the model's behaving it how it is, we can go through that explanation. But you can see here pretty good results in terms of or very good results in terms of that classification. Once we've done the classification, that's where we now need to do the field extraction. So again, we have two types of metadata that we're feeding into this. Again, the system metadata. So if we want to change the language model to do something different at the field extraction stage, then we can do that. But the document metadata we're using is slightly different. So here we're giving what fields should you expect to find in this model, and again some information around those fields. So just kind of showing you guys what the dynamic system prompt looks like. Here we're giving some pretty explicit instructions to the model in terms of how it should behave, and again giving some context to what are the fields you should expect and descriptions of those fields. And you can see in the document date at the bottom, we're also telling it how to format the data. So what is the date format that will be helpful in integrating it into the data platform later on, or in the case of the currency, use the 3-digit currency symbols as well. And what that gives us, for every single file we've uploaded, a output for each. And I should note, we're not expecting a full list for every single file because some of those files simply don't contain that information. But we can see it's correctly extracted the 350,000, it's converted it to a numeric value, and it's converted that very helpful United States currency into the US dollars. And it's also given us the confidence score as well. So it's 100% confident that those are the values that were present in the document. So once we've done that field extraction, what we wanted to do was create a single output with the correct value, so taking into account the changes over time and so on. And this is where we're going to use business rules and some aggregation functions within Databricks to do that final processing. And hopefully by this point you guessed it, all of this is using a metadata approach, so it's all stored within tables, so it's very easy to extend. So if I show you some examples of the business rules, we've got the classification hierarchy. So if you find the value in the first file, so the loss adjuster report, then that is that's the golden source that you should take for that information. but also an aggregation type. So take the data aggregation will give you the latest value. So you can see we're building really that customization in using the business rules to make sure we're getting accurate results. So then from all of those documents that we've uploaded, we get a single line item that we can put into the data platform with the correct loss amount, the correct currency, and we're also showing what document that came from if you do want to go back and check the references. So at this point, if I switch back to the demonstration, so in the time it's taken me to do the demo, we've been able to process those files that I've uploaded. We can see the individual outputs within, so the file level outputs, but also that aggregate value. And as I said, this was a sample, we're running it on 6 documents, but ultimately in the background, we can run thousands and thousands of documents through this approach. What we found as we were doing this as well is the model gave us very good results. So 80 to 90% of the time, we were able to get the accurate results that we were looking for and landing into the data platform. And ultimately, this is because of the level of customization that we were able to build into the solution. And I mean customization in 2 ways. So tuning the model to how we wanted it to act, giving it those instructions so that it knew what it was doing, but also then providing it with the business rules to do that metadata extraction, but also the final aggregation. So my colleagues don't like all the stars, but really the stars are indicating all the points we've been able to add customization into the solution. And the whole point of this slide is to show there was customization throughout that meant we could both meet the requirements for this use case, but also make sure it's extensible to future use cases. And as Trevor mentioned, get a lot better results than some of the off-the-shelf products that they were also looking at. So to wrap this up, I'm going to go back to what we wanted from an ideal solution. So I've shown you throughout the demo how we've catered for those key points. So the solution was able to run through for those few files in the time it took me to walk through the demo, so much faster than we could read and then manually key in the results. We've also been able to really use that process to extract unstructured data from the claims document, but it's easily extensible to extract data from maybe the underwriting documents or different document types. And you can also see how it's maintainable by Apollo. So using that metadata approach, you can simply update the underlying tables and bring in those new documents without ever having to write new code. So with that, I'll wrap up by saying a huge thank you to Trevor, first of all, for providing us some pretty interesting work to do and the collaboration with Apollo, and then secondly, for being willing to present us alongside us today. Trevor's promised he'll stay around during lunch, so he's happy for you to catch him and ask any questions and discuss this further or any of the work that we've done with Apollo over the last few years. So with that, I'll say thank you again to Trevor and hand over to Jay, who's going to take us through the next use case.